For this assignment, we had to take a math test that would normally be given in a grade 3 classroom and adapt it into a problem-solving task using the 6 strategies from Van de Waal.
We also had to show the original version of the task, the adapted version when we connected it to the grade 3 curriculum outcomes, and explained how our changes help students think more deeply, not just repeat patterns.
We chose to focus on growing patterns because it falls under grade 3 patterns and relations. And it's something students often do as just copy and continue without really understanding how the pattern works.
We also based our task on the growing patterns section from Teaching Student-Centered Mathematics by Van de Waal. That section explains that students should build step 1, step 2, and step 3, notice how the pattern grows, describe the rule, and predict future steps, which fit perfectly with our assignment.
The exact outcome we used is PR01 from the Nova Scotia Grade 3 Math curriculum. It says students will demonstrate an understanding of increasing patterns by describing, extending, comparing, and creating numerical and non-numerical patterns using manipulatives, diagrams, sounds, and actions.
Our adapted task matches this because students create their own pattern, describe the rule, extend it to step 10, and explain the reasoning, not just fill in the blanks. The original worksheet was really straightforward. It asked students to extend a pattern like, for example, 3, 5, 7, blank, blank, or it showed students blocks. Step 1 equals 3 blocks, step 2 equals 5, step 3 equals 7, and students just drew the next ones. This kind of task checks if students can continue a pattern, but it doesn't ask them to explain the rule, create their own, or justify their thinking. So it's not really problem solving.
We noticed that in this version, there's only one correct answer. There's no room for student creativity, reasoning, or different strategies. It also doesn't show whether students truly understand how the pattern grows. They could just be copying without noticing the rule.
For this adapted worksheet, we changed the instructions to, "You are a pattern designer." Now students have to create their own growing pattern using drawings, blocks, or numbers, and show step 1, step 2, step 3, write the pattern rule, and predict what step 10 will look like, and then explain how they know they're correct.
Why this is problem solving? This makes the task open-ended. Students make choices and take ownership of the pattern they're building. It's no longer about guessing the next number, it's about thinking like a mathematician, justifying and explaining.
To support students, we would also have a class anchor chart up during the activity.
It would remind them what a growing pattern is, how it increases, and sentence starters like, "My pattern starts at blank and adds blank each time," or "I know step 10 is blank because." This gives students something to refer back to and helps them work independently without asking the teacher every time. The original worksheet only asked students to continue a pattern the teacher gave them. There was one right answer, no choice, and no explanation required.
In the adapted version, students have to create their own pattern themselves, explain the rule, and justify a future step like step 10. There are multiple possible answers and strategies. So this slide really shows the shift from just repeating a pattern to actually understanding, designing, and reasoning about one.
We connected our adapted activity to the 6 problem-solving strategies from Van de Waal. I'll go through each strategy and explain why it fits our worksheet. So strategy 1, allow multiple strategies, or in multiple ways. Students can use drawings, numbers, manipulatives, or tables to show their pattern. Strategy 2, make it an exploration, not just copying. Instead of extending a pattern they're given, they create their own pattern from the beginning. And strategy 3, postpone formal rules. We don't start by teaching equations or formulas. Students notice the rule first through building and describing.
Strategy 4, use visual models. They draw or build step 1, step 2, step 3, which makes the pattern growth visible. Step 5, multiple entry points. So some students might make a simple +2 pattern, while other students might make a more complex ones like +5, or patterns using shapes and numbers. Strategy 6, reasoning and convincing. Students have to explain step 10, how they got it, and why it makes sense. This shows a real understanding instead of just guessing.
So, why this helps learning? This adapted task supports deeper understanding because students are explaining, creating, and justifying instead of just copying. It also supports UDL. Visual learners, hands-on learners, and stronger writers can all show their thinking in different ways.
We realized that by only changing the task instructions, the level of thinking completely changes. It turns a simple worksheet into an actual problem-solving activity. And it shows us how important it is for students not to only get the answer, but to be able to explain their thinking and communicate their math.
Thank you.
Thank you.